Good morning, everyone. I am Vishal, your interviewer for today's simulated engineering job session. Let's. It's pleasure to meet such talented candidates representing various engineering fields. So, I'll be speaking with each of you individually about your background, technical expertise, and how you approach challenges in your area. Let's begin our first candidate, Anjana.
Good morning, Nisar. Uh,
Uh, Good morning, Anjana. Could you please start introducing yourself and tell me about your background?
okay, I'm Anjana, an electronic engineering undergraduate from Faculty of Engineering, University of Laguna. So my main interest lie in the embedded systems, circuit design, and IoT-based automation. So I have worked on several academic and personal projects involving Arduino, Raspberry Pi, and PCB design using such software such as Proteus, LTM Designer. My long-term goal is work as an electronic design engineer, contributing to innovation in the smart systems and sustainable technologies.
That's great, Anjana. Could you explain the difference between the microcontroller and microprocessor and where which is typically used?
Of course, uh, a microcontroller is an integrated chip containing CPU, memory, and I/O peripherals, all in one unit. It's mainly used for specific control-oriented applications such as washing machine, sensors, or IoT devices. So, a microprocessor, on the other hand, contains only CPU and need external components like RAM and I/O interfaces. It used in devices that require higher computational power, such as computer or advanced automation systems. In short, microcontrollers are ideal for dedicated, cost-effective systems, while microprocessors suit complex and multitask environments.
That's impressive, Anjana. Finally, if a critical component in your PCB design suddenly becomes unavailable before production, what steps would you take to solve this issue?
Yes, during my final year mini project, I worked on IoT-based temperature and humidity monitoring system. So initially, we faced inconsistent sensor reading due to voltage fluctuations, and I performed circuit analysis and added voltage regulator and filter capacitors and reprogrammed it. So the ADC conversion for battery accuracy, uh, the result is stable and high precision output. I thought the importance both hardware reliability and debugging discipline.
Good morning, Ishan. Could you please introduce yourself?
Good morning, sir. I am Nishan Namayangana, a computer engineer undergraduate with deep passion for data science, AI, and machine learning. I am experienced in Python, SQL, Tableau, Power BI, and I love turning raw data into meaningful insight that support decision making. My ambition is to become data scientist working on real-world analytics and AI solutions.
That's wonderful, Ishan. Could you explain the main difference between the supervised and unsupervised learning?
Yes, in supervised learning, we train a model using label data where the outcome are already known. For example, predicting whether an email is spam or not. Algorithms like linear regression, decision tree, and SVM. SVM are common here. In unsupervised learning, the data has no predicted label. The model explores pattern or grouping on its own. A good example is clustering, like grouping customers based on their purchase behavior using K-mean clustering. Supervised learning helps in prediction, while unsupervised learning is mainly used for pattern discovery and data exploration.
That's excellent. Can you share the project where you use data visualization to solve the problem?
Certainly, during internship, I work on customer churn prediction project. After building a model, I visualize trends using Tableau dashboard and Seaborn heat maps. The visualize revealed that most churn came from customers with long complaint history and low service engagement. Presenting this insight to management helped them launch a target retention program, reducing churn by 15%. It reinforced my brief that visualize make data insight more pervasive and actionable.
Very interesting, Ishan. Finally, if you discover a data set with a missing or inconsistent values, how would you handle this issue?
I would start by conducting data profiling to understand which attributes have missing data and whether they are random or systematic. If the missing problem is small, I would use mean, median, or mode imputation. For large gaps, I might use KNN imputation or build a predictive model to estimate missing value. I'd also standardize formats that handle outliers carefully. Maintaining data quality is essential because even the best algorithm fail on poor data.
Okay, that's a great answer. So, thank you for attending for the interview. Thank you.
Thank
Ishan.
you, sir. Thank you, sir.
Good morning, Sajinta. Could you introduce yourself to us?
Good morning. I'm Sachinda, an AML associate pursuing a degree in computer engineering. My key interests include deep learning, NLP, and model optimization. I have built several models using TensorFlow, PyTorch, and Keras. And recently, I'm working on the sentiment analysis project that classifies customer reviews. And my goal is to become a AI engineer who develops a smart system that solve business and social challenges.
Excellent. So, can you tell me main difference between the machine learning and deep learning?
Sure. Machine learning focuses on algorithm that learns from data using hand graph features like decision trees and support vector machines. And deep learning, on the other hand, is a subset of machine learning that uses multi-layered neural networks to automatically learn features from raw data, such as image, speech, and text. For instance, in the image recognition and traditional machine learning might require manually extracting features like edges or colors histograms, while deep learning modes like CNN learns these patterns automatically. This makes deep learning more powerful, but also more data and compute intensive.
That's great. So, good answer as well. So, can you describe the real project where you implemented AI successfully?
Yes. In one project, I developed a sentiment analysis system using LSTM neural network. The datasets contain thousands of product reviews, which I pre-processed with tokenization and ability techniques. The model achieved over 90% accuracy, and but I built a dashboard using Plotly for real-time sentiment tracking. This project taught me about the model evaluation, parameter tuning, and the importance of balance scale.
That's excellent. Suppose you train the model performs well on training data, but poorly on real world data. What could be the reason? How work on poorly on real data? So, how would you fix it?
That is the case of overfitting. It's happened when the model memorizes training data instead of generalizing from it. To solve this, I will use regularization techniques like dropout, list of in, and cross validation. I would also increase the dataset diversity through data augmentation and ensure my training and training data come from similar distribution. Monitoring model performance on validation tests throughout and training helps maintaining generalization.
So, thank you, Sachin. That's a great interview. Okay. Good morning, Nanda sir. Could you start introducing yourself?
Good morning. I'm Nadusara, an engineering undergraduate specialized in network engineering. So I'm experienced in configuring routers, switches, and firewalls. So I have worked with Cisco Packet Tracer and Wireshark with related to network engineering. So my goal is to become a network administrator. So focusing on maintaining and secure, efficient communication systems for organizations.
That's good. Could you explain the difference between the TCP and UDP protocols?
TCP is been a transmission control protocol, so it connection oriented. It ensure data reliability using acknowledgement and tree transmissions. So it's used an application like web browsing and emails where accuracy is critical. So UDP mean user datagram protocol. It's connectionless, not like TCP. So it sends data faster, but without a guarantee. So if of delivery, making it unsuitable for real-time applications like gaming or video streaming. So TCP focus on reliability, while UDP prioritize speed and efficiency.
That's nice. So tell me about you successfully solved the network related issue.
In during university lab session, multiple users were unable to connect to a shared database. I systematically checked the DHCP configurations, subnet mask, and firewall rules. The issue turned out to be a misconfigured static IP that caused address conflict. After correcting and restarting the DHCP server, it all regained access. So this taught me to diagnose from layer to layer. I start from physical to applications level.
That's excellent. That's excellent troubleshooting as well. So imagine the company network suddenly goes down during the peak hours. What's your immediate response for that kind of situation?
Okay, first I start calm and immediately check network connectivity using tool like ping, traceroute, and network monitoring dashboards. I verify power and hardware status of core devices. Check for loopback of for faulty switches, and if needed, switch to a backup route. Once the issue is fixed, I document the route cost and recommend preventing measure like redundancy, automated monitoring, and schedule maintenance.
So thank you, Nasara, for participating in the interview. Thank you. Morning, Inupa. Could you please introduce yourself?
Good morning, Vishal. I'm Anupa. I'm an ML engineering student with strong enthusiasm for computer vision, NLP, and automation. I've implemented models using TensorFlow, OpenCV, and Hugging Face transformers, and recently worked on an AI-based waste detection system. My aim is to create AI solutions that contribute to sustainability and smart city development.
Oh, that's great. Could you explain what computer vision means and how it works?
Sure. Computer vision is a field of AI that enables machine to understand and interpret visual data, such as images and videos, similar to humans. It uses deep learning models like convolutional neural networks to extract features such as edges, colors, and shapes from images. These models are trained on large labeled data sets to identify or classify objects. Applications include autonomous driving, medical imaging, and facial recognition, all which rely on vision-based learning and inference.
Okay, excellent. So, can you tell me about your waste detection project in your CV? Can you give me more details about it?
Of course. My team and I built a real-time waste classification system using YOLO and OpenCV. The model was trained on thousands of labeled images of recyclable and non-recyclable items. We integrated with a camera module that could detect and classify waste on a conveyor belt. We achieved around 88% detection accuracy, and the system could even differentiate between paper, glass, and metal. It demonstrated how AI can directly support environmental sustainability through automation.
Oh, that's very innovative. So, suppose your model produces biased results. How would you handle it?
I begin by analyzing the training data for imbalance. For example, if certain waste category has fewer samples, then I apply data augmentation or resampling to balance the data set. I also test and model using fairness metrics and adjust hyperparameters if needed. Finally, I document the ethical implications of model decisions, ensuring transparency and fairness in the system's behavior. That's
Okay. Thank you, Venupa. And thank you, everyone, for your insightful responses. I am truly impressed with your technical expertise, communication, and professionalism throughout this session. So, thank you, everyone, for joining. Thank you.
Thank you.